What we're going to do now is we're going to find the length of this arc right here. I don't know, let's say, what do you think, 45 degrees? We'll use one that we're, okay, there we go, there's the pen. Let's just say this 45 degrees. But 45 degrees, if we can't remember what 45 degrees is, what do we have to do to it? We have to convert it, right? So let's do it one more time. So you should be good at this conversion thing by the time you get to this homework. So 180 here, pi right here. Why do we do that? So the degrees cancel each other out, right? And let's see, 45 goes into 90 twice, so into 180 how many times? 4 times, so it's pi over 4. So I'm not going to use 45 degrees. I'm going to use what 45 degrees is in radians. I'm going to use pi over 4. So now I can use this equation right here. So S equals the arc length equals the radius, and we'll use what we have right here is 5 inches, times what? Pi over 4. Okay. Now, you actually put this in a calculator. You actually put pi 3.14 in a calculator. So this thing's covering up my calculator. Oh, there it is right there.
Should we use our pi buttons?
You know, I'm not really sure. What I should have looked to see what the what the book does. I'm going to use the pi button. Okay, so let's use the pi button. On this calculator, it's second function down here. Where is it? Right there, that up thing. Okay, so that's pi. Actually, let's do this. Let's write it just like this. Let's write it 5 pi over 4. All right, so 5, and then pi right here over 4. Okay, so it's 3.9. Yeah, that's right, isn't it? Yeah. I was just wondering if you needed parentheses around that. I don't think it makes any difference. I'll tell you what, just for fun, let's just try that. Okay? For fun. When I say 5, I don't think it makes any difference. It doesn't? You already tried it? Yeah, I'm a little slow using this thing. 5 pi over 4. Let's just see. 1. Yeah, it's the same thing. So 3.9. So the length of this is about 3.9 inches. And that's what it is. If this was 45 degrees right here, then this, if the radius was 5, now this probably is a little bit more than 45, wouldn't you agree? Okay, I didn't measure it out to see. But that right there would be 3.9 inches. All right, let's do an example from the book, and it's a little more word problem-ish. All right, so it's not that hard. Look at it. It says a monster truck tires have a radius of 33 inches. All right. Monster truck. Well, I guess because it's a big old 33 inches. 33 inches is pretty big. I mean, it's about
5.5 feet.
That's the radius. I mean, that's half of the 33 inches, probably around there somewhere. Okay, so that's half of the tire. That's pretty big. So you double that. That's how big the tire is. Would you call that a monster truck? Probably. It's probably big old thing. So anyway, it's 33 inches, and it says how far does a monster truck travel in feet? Okay, how far does it travel in feet after just 3/4 of a tire rotation? So 3/4 of a rotation. And how far in feet does it travel? How far in feet? Okay, now it's important because they give the radius in inches, don't they? How far in feet does it travel? All right, well, let's put a circle here. Let's use this one. Oops. Come on, grab it. There it goes. All right, so this is 33 inches. How much time do I have? I got a few minutes, right? Okay, so that's 33 inches, and we want to find out how far does it travel when it goes 3/4 of a rotation. Now, how far does it travel? I mean, the tire is going to roll, isn't it? Like this. Okay, if I find out how far it travels horizontally along the ground, can't I just find the arc measure of 3/4 of the tire rotation? Do you see that? As the tire rotates around like this, it's going to go horizontally along the ground. Okay, for each inch that it rotates this way, it's going to make an inch on the ground. Make sense? All right, so I got to figure out 3/4 of a rotation. Actually, let's think about going this way, just because it actually doesn't make any difference, does it? What letter do I use? This one. So 3/4 would be here. So really, what's it doing? It's rotating around that much right there. Which in degrees is how much? 270. We've already done this. I'm not going to waste any time on it. What is that in radians, though? It's 3 pi over 2. All right, we've already done that. All right, so now we're ready to do everything we want to do, okay, except for the conversion. We'll do the conversion at the end. I guess you can convert now and work on it, or I'm going to just wait to the end of conversion. It's a lot easier to work with 33 inches. So what is our formula? S, which is the arc length, and that's what we're trying to do, isn't it? This is going to be ugly, watch this, but we're trying to find this length right there, almost. All right, so we're trying to find that arc length right there. So it's equal to r theta. Theta has to be in radians. This is already in radians. We put it there. So the radius is 33 inches. Just remember that's in inches, though. Okay, so we have to convert it to feet because that's what the question says. Times pi, which is 3 pi over 2. All right, we use our calculator again. And it's, what, 99 pi, right? Couldn't we do that?
Yeah.
99 pi. What did I, oh, I didn't hit the second function. Let's try it again. 99, I guess I didn't hit second function. There we go. 99 pi divided by, come on, there we go, 2, equals 155.5. So 155.5, what though? What did I just find that in? It's in inches, because 33 is inches, okay? We're not going to talk about this now, but radians is kind of dimensionless, okay? Look, on a little tiny circle, this degree would be 3 pi over 2. On a big old huge circle, this would be 3 pi over 2. So it really doesn't have true dimensions like we know inches and feet. Well, we just do this. Watch, I'm going to do another conversion. We've kind of talked about this already. Danny, watching? So it's over 1 times. Now, if inches on top, what do we need to do? We kind of talked about degrees and radians. Inches is on the bottom. And what are we converting it to? Feet. Now, remember we said pi and 180 were equal to each other. Well, what are equal to each other with feet and inches? 1 foot is equal to 12 inches. Have you ever done conversions like that? Using that thing right there? Okay, good. So the inches go. So now all we do in our calculator is go to that 155.5 and just do what to it? Right, take that and divide it by 12. All right, and then that's 12.95, or let's just round it to feet. So it's about 13 feet. So 3/4 of a rotation, it goes 13 feet. We good with that? All right. Let's go 11 to 40, okay? I looked at them. I took a pretty close look. All right. That's all right. I'm fine with that. It's not that hard. Look, because I remember the 6 things. Remember we said, oh, that's a little long. We did one of those in class, and it only took just a minute. It wasn't that long. Again, draw angles. Look, all you got to do is just do this, right, and then just draw that, right, and then say what. That's all you have to do to draw an angle. How long does that take? Paco, you don't want to be on YouTube all whining about your assignment, do you? You should say, is that all you want to give us? Give us more, please. All right. Well, let's sign off. Everybody say bye.
Bye.